So yeah, today we are going to start the next part of this WTIR playlist, and this will be basically the part 5 in which we will discuss about what is this hardware basics, and we'll also discuss about distributed indexing and dynamic indexing. So if till now if you have any query, you can ask me in the comment section, and you can also share your feedback. So let's start without wasting the time. Let's discuss what is hardware basics. In previous video, we have discussed what is stop words. Okay, so I told you stop words are nothing but the commonly used words that are as, the, and, a, in, that, it, is, of, and that, be, by, for, and etc. So basically, what happens? Search engine basically ignores these stop words. Okay, but there are some points of time where these stop words are basically very much important. Okay, and I told you the case where these are very important, like when we are giving a phrase query, so we need them like president of India. Okay, so at that time stop words are very much important. So we have discussed about what is stop words, and we have also discussed about the term steaming and steaming algorithm and some terms like invisible web and all that. So today we'll discuss about the hardware basics. So see, let's discuss. Let's read the statement that is access to data in memory RAM is much faster than access to disk secondary memory. Okay, so as we all know, like you are a computer engineer, so you should know these basic thing. Like if you are accessing the data from main memory, or you can say a RAM, so that is very much faster than if you are accessing the data from the disk, or you can say secondary memory. Or you also know this thing that for executing any instruction by CPU, your instruction should be there in the main memory, not in the secondary memory. Okay, if your instructions and if your commands are there in the secondary memory, then they can't be executed. First you have to shift them to the main memory, or that is RAM, or you can also say the primary memory, so that your instructions can be run. Okay, so I'm telling you that access to data or instruction, you can say, in main memory, or you can say primary memory, or you can say RAM, is much faster than access from a disk or a secondary memory. So basically in hardware basics concept, like hardware basics, you should understand this concept. This will help you in understanding another concepts. So hardware concept, as the name suggests, we are discussing about the hardware. We are discussing about the memory. In memory we are discussing about the primary memory, secondary memory, and all that. So I'm telling you in the first point that accessing the data from the main memory or the primary memory is much faster than accessing a data from the disk or the secondary memory. I think some of you basically know this thing. And next point, just read: instead of transferring large chunk of data from disk to memory, we will transfer small chunk. Okay, so I told you earlier also that if you want to execute some program or execute some instruction, so your data or your program should be there in the main memory. If your program is there in the secondary memory, so you first need to transfer it into the main memory to execute that particular program. Okay, so we are saying here, like we are just not transferring the large chunk. Basically here you can say a piece of data or a bundle of data. Okay, so chunk is basically nothing, the piece or the bundle of data. So here we are saying that instead of transferring large chunk from secondary memory to main memory for executing that particular program, we will transfer the small chunks. Okay, because if we are transferring large chunk, that it will definitely take large time, or there can be some data lost, or some data instruction can be lost. So instead of transferring the large chunks from disk to memory, or from, you can say, secondary memory to primary memory, will transfer the small chunks. Now this input output is block based. Now what is this block based? You see, block based, this basically comes here like block short based index. Now just you leave this point, because these BSBI and SPMI we will discuss in further. Like in here we have only the small amount of content, but in further notes I have a large amount of content about them, and we will discuss them in depth and will have a crystal clear understanding. Okay, so just leave this point. Disk input output is basically block based. I will tell you this in further video, and we'll discuss about this BSBI. Now here block size is basically 8 KB to 256 KB. Basically you can understand block size is basically when we are transferring the chunks, so you can also understand these chunks as a block. So when we are transferring these blocks of data from the disk to memory, so the sizes of blocks basically ranges from 8 KB kilobytes to 256 kilobytes. Okay, now servers used in IR, that is information retrieval systems, now have several GB of main memory, sometimes TB. Listen, I told you that main memory is very much important if you want to execute your program, your instruction, or anything. Okay, it doesn't depend if your program or your instructions are there in the secondary memory and you are thinking that yeah, you can easily execute them. Okay, yeah, basically you know that secondary memory, basically we have the large sizes of secondary memory in our systems. But nowadays, basically servers that are used in information retrieval systems, they have the GB of main memory, that is gigabyte of memory, or sometimes they also have the TB of main memory. TB basically it stands for terabyte. Okay, that is greater than the gigabyte. Okay, so nowadays the servers are there. The servers of information retrieval systems basically have the large size main memory that can store the large amount of data, large amount of program instruction that can be easily executed. Okay, so this is about the hardware basics. In hardware basics, we basically understand that the for executing some program and for executing some instructions, we should first put them into the main memory, or you can say primary memory. This they both are same. So that is very much important that you have to put your data program instruction into a main memory for executing it. If you have your data in secondary memory or your program in secondary memory and you want to execute it, so first you have to transfer it into the main memory, and instead of transferring into large chunk that will take last time, cost will also increase. You should transfer it into the small chunk that will also reduce the time and also increase the efficiency. And another thing we have discussed, that the block of chunks that we are transferring from secondary memory to main memory, their sizes basically varies from 8 KB to 256 KB. And we have also discussed that the servers basically that are used in information retrieval system nowadays have a large size main memory that can hold a large amount of data, instructions, and program for executing. Okay, so they are basically sometime TB, sometime GB. Okay, that is gigabyte and terabyte. So that is about basically hardware basic. You should know it for understanding the further concepts. So now, without discussing this BSBI, I told you that BSBI and that all we will discuss in the further lectures where I will be having the large content about this. We will also SPM also we will discuss further, because here I have only the short note about them. But in further notes, you will see a uh, large content of them, so that you can have a crystal clear understanding about it. Yeah, now understand what is this distributed indexing. Okay, that is very much important, that can came into your exam in 1 marks, 2 marks, and that can be asked, and you should also know it. So let's understand what is this distributed indexing. As the name suggests, distributed. Okay, that is not basically at a one place. No, it is distributed. Now understand, we have dynamic collection of documents. Now what does this mean, dynamic collection? So basically in computer field, you should know what is the static and dynamic. Static is basically, our name suggests itself, static, that is basically you can say that is static, that is not moving, you can say that is not updating, or you can say that is basically static, that does not have any motion, or that is not moving, or that is not like changing. You also can say that is static. Basically it is at place, is it like if it is at place, some place before 1 month, and now after 1 month it is also at the same place, that is static. Now what is dynamic? You will also see it in the programming concept, dynamic, like runtime. Okay, dynamic basically runtime, basically you will understand it by it. So dynamic collection basically which is changing periodically. Okay, which is changing. Dynamic is means that is not stable, that is not static. No, that is dynamic, that is changing. Okay, like your growth, your self growth is basically dynamic, that is not static, that is basically stable, you are stable at one place. No, you are dynamic, you are changing. Your body size is changing, your like hormones are changing. You are also changing yourself in academic performance and in everything. Okay, so you are dynamic, you are changing. So dynamic basically that changes periodically. Okay, so basically we have the dynamic collection of documents. It means documents which are there in our internet, or which we are there in our www. So we have dynamic collection, like every day, or you can say every, not every day, every second, every minute, each new documents were adding into our information retrieval system, or you can say onto our internet. Okay, so number of documents are adding. So we have a dynamic collection. Dynamic collection means changing documents, or changing periodically, new documents are adding periodically. Okay, so you cannot say like you have a static, like if you have a 10 documents on internet, so there will be 10. No, they are changing, they will 11, 12, 13, 14, 15, they will change. Now you have a like huge amount of documents. I cannot say, I cannot tell you the approx number, the how much documents you have. No, you have a dynamic documents. Each day, each and every day new documents are added. You can also add your document. You just go and just publish your website, just add some pages there. So you are just also adding a document. And at the same point, another one who is sitting in another country, he's also uh, publishing a document onto the web. Okay, so we have a dynamic collection of web that you have to understand. Now, data will not fit into the hard disk, but will fit into the multiple machine. Now see, I told you that we have a dynamic collection of documents. Okay, now dynamic collection of documents basically means that we need to store into we need to store them also. Okay, we need to store them in any place. See, but if we have a dynamic, but we have a capacity, we have a dynamic collection of documents were increasing day by day, or you can say at in particular second, in particular minute, they were increasing. Okay, they were adding new documents, were adding into the web. But we have a fixed capacity of memory, or you can say a hard disk. Okay, so what happened? So we need to store into the multiple machines. Okay, understanding my point? So you need to store into the multiple machines, because data will not fit into the hard disk, because data is increasing day by day. I'm telling day by day, but yeah, it is increasing minute by minute, second by second, it is increasing. Okay, getting my point? So it is not like that it is only increasing day by day, or yeah, yet it is increasing second by second, but we have the fixed, or a particular capacity of hard disk or memories that can store the data or documents. So for that reason, what we will do, we will store them, or we will fit that data into the multiple machines instead of storing them into a particular machine. So that is basically the distributed indexing concept comes here. Distributed, like the data is not stored at a particular position, it is distributed into a multiple machines. So that basically the meaning of distributed here, that the data is not fit into the particular hard disk, it is fit into the, or it is stored into the multiple machines. Basically the data is distributed now. So next point is we need large computer clusters to create a web index. Okay, now that is very much clear, that we have now we have stored the data into multiple machines. Now we also need a large computer cluster to create a web index. Like creating a web index is very much important, because if we will not create a web index, I told you into the invisible web definition, that if we will not create the indexing of a particular data or a particular document, then that will come into the invisible web category, that will not be shown to the user. And I think you don't want that your website that you are publishing today, that will not shown to the user. Okay, so for that, indexing should be must. And now we need the large computer clusters to create a web index, because we have a distributed data, multiple machines have our data, not a particular machines. So we also need a large computer clusters to create a web index. Next point is basically web search engine uses this distributed indexing algorithm for indexing construction. So I told you that we have a large amount of documents. Now we have a huge number of documents adding each second, each minute, they are adding. Okay, so for them we don't we need a multiple machines to store that data, to fit that data. We also need the large computer clusters to create a web index. Now basically these web search engines uses this distributed indexing that we were discussing. Distributed indexing algorithm web search engine uses for index construction when our data is stored at the multiple machines. So this is basically about distributed indexing. I know that you have basically have a crystal clear understanding of this distributed indexing. This distributed indexing is basically nothing, but it is only um, the algorithm distributed indexing, basically the algorithm that was used by these web search engines for basically constructing this index construction. Index construction, why? Because now our data is not stored at a particular machine, it is stored at the multiple machines. Now our data is basically distributed, and for that we need distributed indexing, because indexing is must, and for that we need distributed indexing. So basically web search engine uses this distributed indexing for creating the for constructing the index. Now another indexing comes that is very much important, that is dynamic indexing. Dynamic indexing, I told you the meaning of dynamic basically changing periodically. Okay, that is changing periodically. The opposite of dynamic is static, that is stable. That is static, that is not changing, that is stable. And another is dynamic, that is changing periodically. Okay, or you will also understand it when you go deep dive into the programming, so you will understand dynamic basically at the runtime. So the particular thing which is that the runtime, at that time it is changing. Like documents onto the web are there, they are also present at that time. And at the particular time, at the same time, at the runtime you are adding your website to the web. So at the runtime the web pages or the documents or the data is changing, so that is dynamic. Okay, so dynamic indexing, every time a new document is inserted, modified, so we need to update the index. I told you, every time, every single second, new documents are inserted, modified. Okay, so you can also insert your website, you can also modify your existing website, so we need to update the index also. Okay, like I told you that you have published your website, so web search engine also index need to index your website also, so that user can um, go through your websites. So dynamic indexing is basically every time a new document is inserted, so we need to update the index. If new document is included quickly, so that new documents can be included quickly. Now here comes the a concept, that is main index and auxiliary index. What happened? Like also I also write it into the the thing which will be clear to you in very basically. Like in main index disk में I write it like, and auxiliary index is basically main memory में save होगा. Okay, so what happened? Okay, no, I can tell you this concept in Hindi so that you can have a crystal clear understanding. See, like we have a main index, we have a auxiliary index. What happened? We have now created, like I told you the problem. What is the problem in dynamic indexing? Like why we are introducing this dynamic indexing? Because at every time new documents are inserted or modified, so we need to update the index also. Okay, this is the problem, and now dynamic indexing will come into the play. We'll understand what is this. Now main index and another is auxiliary index. Oh, these two indexes are there, but earlier we have also only the main index. Okay, so here the auxiliary index concept is introduced. Now what is this auxiliary index? ये auxiliary index क्या है? इसमें जो है हमारे जितने भी न्यू डॉक्यूमेंट्स है वो स्टोर होते हैं ना. Okay, and now main memory में save होगा, and that is main index is basically into the disk. Disk is basically the secondary memory. Now what happened? Auxiliary memory basically stores the new document, and this main index basically stores the previous documents. Okay, now see, now if a query is requested, if a user go to the search engine and he and she raised some query. Now basically what happens, search will happen into both the indexes, in main memory and in main index and in auxiliary index. Search will happen in both the indexes, and the output which came will be merged. Okay, so the merge the result. Periodically merge auxiliary index to the main index. Merging cost basically depends on how we store new documents. See what happened. Now we have created two index, that is main index and that is auxiliary index. Auxiliary index is basically storing the new documents. Okay, and at time to time, or you can say periodically, this auxiliary index will merge into the main index. Okay, and the merging code basically depends on how we store the new documents. Are you getting the point now? Are you getting? That is very easy, very easy. If you have any query, you can ask me in the comment section. We have main index, we have auxiliary index. Auxiliary index is basically storing the new documents. Main index is basically having the previous documents. And at periodically, or we can say at time to time, we are just merging this auxiliary index into the main index. If a user is requesting any query, so the result will be the searches will be occur from both these, like in main index and in auxiliary index, and the result will be merged and will be shown to the user. Now we have some drawbacks. See, issues with auxiliary and main index. So now just we will discuss the issues. What are the issues in this auxiliary and main index? See, first issue is frequent merges. See, I told you that we will also merge this auxiliary index into main index. So this frequent merges will also an issue, because periodically we need to merge auxiliary index into main index. So that was basically creating an issue, because frequently we have to do that thing. Next is poor search performance during index merge. See, if a user is raising a query, and at that same time we are merging our auxiliary index into the merge index, so that at that same time if a user came and that raises a query at the same time, so that can also reduces, or you can say provide a poor search performance. Because if like I am a user, I am just searching, I am just raising a query onto the Google search engine, and at the same time at backend this auxiliary index is basically merging into the main index at that same time, so that can also affect my search performance at that time. Okay, during index merge, you can say poor search performance during index merge can also uh, be this can also be an issue in issue with auxiliary and main index. So this is about distributed indexing, dynamic indexing, why compression. We'll discuss this in next videos. We'll discuss. So this is all about this video. Thank you.